Enormous, greater than the massive Jupiter, with a measurement of right around 140,000 kilometers, the ruler of our planetary system, is so enormous that the Earth would hypothetically squeeze into it more than 1,300 times at the same moment. The huge gas giant is around 2.5 times more enormous than the wide range of other 7 planets in the planetary system combined. But did you know that the planetary giant is a real Quick Gonzales? In fact, Jupiter only needs a little less than 10 hours to rotate around its own axis, making it the fastest rotating planet in our home world. But besides its charming beauty, Jupiter is also the scene of gigantic storms and destructive radiation. What secrets lie stowed away underneath its thick clouds of mist? What do we know about the Great Red Spot, which is bigger than Earth and whips across the planet's outer layers at a crazy speed of up to 680 kilometers per hour? And overall, how could our own planet never have formed if Jupiter hadn't been rampaging through the solar system like a frenzied berserker in the beginning? Was Jupiter always like this? Well, essentially, that applies to the formation history of our planetary system. A couple of years ago, scientists at the University of Beast were the first to successfully determine the true age of the imposing gas giant. However, since the celestial body has no solid surface and therefore can't provide rock samples, the scientists had to take a little diversion in their age calculation and reach their conclusions from shooting stars. The main takeaway, however, was the realization that Jupiter had grown to 20 Earth masses in under 1 million years after the formation of the nearby planetary group, and that its development was completely finished after another 3 million years. By comparison, Earth, whose mass is 318 times smaller than that of Jupiter, took a walloping 100 million years to reach its planetary completion. And while the mighty giant is not only the biggest but also the oldest planet in our solar system, it was once formed from the dust and gases left over from the formation of the Sunday April 6 billion years ago, an inventory of material that is also reflected in the structure of Jupiter. Much like the Sun, the gas giant is fundamentally made out of hydrogen and helium, which, unexpectedly, also explains its nearly low mean density of 1,330 kilograms per cubic meter. But despite the Sun and Jupiter being undeniably made of the same fabric, there is now an average distance of 778 million kilometers between them. The double XXL's planet orbits past the asteroid belt between the orbits of Mars and Saturn, and thus takes about 12 years to orbit our central star. Well, strictly speaking, that is not entirely correct either. Since, if we are very careful about the facts, Jupiter does not orbit the Sun at all. But what is meant by that? To figure this out, we need to bring a little diversion into the universe of barycenters. The barycenter describes only the center of mass that planets and stars orbit around together. This is generally closest to the object with the greatest mass. Since the mass of the Sun is 330,000 times greater than that of the Earth, the barycenter in this case is extremely close to the center of our mother star. However, as already mentioned, Jupiter is fundamentally heavier than our home planet, and because of this, we find the center of gravity of Jupiter and the Sun not at the center of our home star, but right outside the outer layer of the Sun. Jupiter wanders off as a general rule. The greater the mass of a body, the stronger its gravitational pull on another body. And since Jupiter has a lot of mass, as mentioned, we're talking about a significant degree of around 318 Earth masses. Its gravitational force impacts the structure of the solar system in various ways, and that starts right at home. We now know of 95 moons that are bound to Jupiter's gravitational grasp. But that's not all. The subglacial sea of Jupiter's moon Europa is even thought to possibly harbor extraterrestrial life. However, further studies are needed to see how much this intriguing hypothesis ultimately matches reality. So far, the gas giant has been the focus of research-based missions and flybys multiple times. In fact, the NASA probe Juno is still devoted to the task of investigating the Jupiter system in detail. Moreover, scientific support is already on its way. The ESA probe JUICE set course for Jupiter on April 14, 2023, and is scheduled to arrive at the gas giant in July 2031. Up until now, so many missions have focused on it, but if we now turn to the exacting fascination of the gas giant, we see that its gravity exceeds that of Earth by more than 2.5 times. And that Jupiter, in turn, also acts as a sort of natural defensive shield. At the end of the day, due to its impressive mass, its enormous gravitational field diverts comets and asteroids that could otherwise hit Earth. However, proximity to such gigantic planets is not always an advantage. One study concluded that the attraction of planetary giants not only deflects risks but also, at times, slings smaller planets out of the habitable zone. And speaking of being catapulted out, Jupiter also has a history as an enormous destructive force. Scientists now expect that the gas giant was originally formed several times farther away from the Sun than its current orbit suggests. Moreover, there have long been signs that Jupiter even briefly migrated into the inner solar system. In doing so, on the one hand, it caused unprecedented chaos, and on the other, it enabled Earth to form. The corresponding simulations by the researchers showed that Jupiter's gravitational shift carried massive amounts of debris and planetary building blocks with it. We're talking here about planetesimals up to 1,000 kilometers in size.
And a sum of 10 to 20 Earth masses of material, yet it's in the nature of things that this planetary stroll of a somewhat different kind did not stay without consequences, because it really set off a genuine chain reaction of space rock impacts, which obliterated the larger planetary core. Furthermore, it made an enormous piece of the garbage dive into the Sun. The once extremely thick growth circle close to the Sun was, in this manner, seriously dispersed in the impacted district, and the situation only quieted down when Saturn formed farther and Jupiter reversed its movement. Heading due to this, all in all, Jupiter's entry cleared the inside of the early planetary system unfilled and, consequently, cleared the way for the second wave of the arrangement of small, rocky planets. What's more, our Earth was also among them. However, this situation is also ready to provide an explanation for the abnormality of the solar system. Because in scarcely some other known system do the deepest planets begin as out of sight and have as little gas as our own. Rather, most extrasolar gas giants or super-Earths orbit their host stars very closely and rapidly, and they often take a couple of days or months to complete an orbit. Why the Great Red Spot shudders is unclear. However, if we now withdraw ourselves from the fierce history of Jupiter and, instead, investigate its optical appearance, we immediately notice the strange region of the planet. What at first might look like a stylish stripe design is, as a matter of fact, a series of almost equal groups of clouds that can be seen even through small telescopes. These groups range in color from white to blue, and scientists recognize the lighter zones and the darker belts. While the zones are fundamentally cooler and denser than their partners and also contain rising gases, their lighter tone is probably due to ammonia ice. However, why the belts appear significantly darker is not yet fully understood. But in principle, scientists expect that phosphorus, sulfur, and maybe even hydrocarbons are present in them. Surprisingly, scientists have noticed a cyclical color change in the visible bands every 4 to 5 years, which might be connected to cyclic motions of Jupiter's magnetic dynamo. Moreover, the zones and belts are limited by supposed planes that race over the outer planetary layers at wind speeds of about 300 kilometers per hour, compared to the speed of the Great Red Spot. However, that isn't everything. The largest twister in the whole solar system actually moves at rates of up to 680 kilometers per hour. Anyway, it's not known which chemical elements are responsible for the red coloring that gives it its name. However, what is known is that the massive anticyclone is currently around 1.5 times the width of the Earth and has been raging on Jupiter since at least 1830. By comparison, the wind vortices in the Earth's atmosphere generally belong to the past after a few weeks. Despite its extensive age, the Great Red Spot has now contracted considerably. While its length was still estimated at 40,000 kilometers during the 1880s, it is now only 16,500 kilometers. NASA thinks this is due to interactions with other smaller storms. Furthermore, could its own decrease in size also be the reason why this enormous design is literally shaking? Probably not, But novel observations with the Hubble Space Telescope have recently shown that the Jupiter storm changes its appearance several times during its 90-day movement from east to west and back again. The Great Red Spot, on the other hand, limits and expands as it floats faster and slower. These motions also go hand in hand with cyclical variations in the size and brightness of the storm's eye, which, however, are inversely correlated with the drift rate. In fact, the Great Red Spot and its eye are at their largest and brightest when the twister is drifting at its lowest. The characteristic changes slightly from day to day, and over time, it looks as though the Great Red Spot is shaking like a leaf. But why is that? Well, we don't know. However, this is the first time that such a wavering has been seen in a Jovian storm. The researchers still can't provide the corresponding hydrodynamic explanations, but the assumption is that it will be simply the interactions with the fierce shear winds of the storm bands north and south of the Great Red Spot that are responsible. Nevertheless, what will happen next, given the previous decreases in size? What are the chances that the colossal design will one day totally vanish from the Jupiter scene? Well, this is precisely the question that the scientists are currently addressing. They now need to find out in detail whether there is a lower size limit, past which such an enduring twister becomes unstable. We genuinely hope you enjoy participating in our scientific exploration while never missing a new video from us. Again, we'll see you soon.